Welcome to EDU World Space.
So let's solve this question. So in this question we have summation f of x is equal to 0 for equilibrium. So n cos d theta by 2 plus v sine d theta by 2 minus n plus dn cos d theta by 2 plus v plus dv sine d theta by 2 equals to 0. This is equation number first for equilibrium. Summation of f of y is equal to 0. So n sine d theta by 2 minus v cos d theta by 2 plus n plus dn s sine d theta by 2 plus v plus dv cos d theta by 2 that is equal to 0. Equation number 2, where n is normal force and v is shear strain. For equilibrium, summation m x equals to 0, that is t cos d theta by 2 plus m sin d theta by 2 minus t plus dt cos d theta by 2 plus m plus dm sin d theta by 2 that is equal to 0. Equation number third for equilibrium, summation of my is equal to 0, that is t sine d theta by 2 minus m cos d theta by 2 plus t plus dt sine d theta by 2 plus m plus dm cos d theta by 2 that is equal to 0. Equation number 4. Here t is torsional moment and m is bending moment. As the differential d by theta by 2 is very small, since cosine functions becomes sin d theta by 2 is approximately equal to d theta by 2. Cos d theta by 2 is approximately equal to 1. Substitute d theta by 2 for sin d theta by 2 and 1 for cos theta d theta by 2 in 1. So n into 1 plus v d theta by 2 minus n plus dn into 1 plus n plus v d theta by 2 minus n minus dn plus v d theta by 2 plus d 2v d theta by 2 minus dn plus dv d theta by 2 that is equal to 0. So v d theta minus v dn dn plus dv d theta by 2 is equal to 0. Neglect the second order term, that is v d theta minus dn is equal to 0. So dn by d theta is equal to v. Therefore, required relation is dn by d theta v. Substitute d theta by 2 for sin d theta by 2 and 1 for cos theta by 2 in 2. So n d theta by 2 minus v into 1 plus n plus dn d theta by 2 plus d theta by 2 plus v plus dv into 1 is equal to 0. So this will becomes n d theta by 2 minus v plus n d theta by 2 plus dn d theta by 2 plus v plus dv equals to 0. So this becomes twice of n d theta by 2 plus dv plus dn d theta by 2 equals 0. So this becomes what? N d theta plus dv plus dn d theta by 2 equals 0. Neglect second terms. So this becomes n d theta plus dv equals 0. So dv by d theta equals minus m. So this is our required relation. Now substitute d theta by 2 for sin d theta by 2 and 1 for cos d theta by 2 in 3. So this becomes t1 plus m d theta by 2 minus t plus dt 1 plus m plus dm d theta by 2 equals 0. This becomes t plus m d theta by 2 minus t minus dt plus m d theta by 2 plus dm d theta by 2 equals to 0. So this becomes what? Twice of m d theta by 2 minus dt plus dm d theta by 2 equals to 0. Neglect the second order. This becomes m d theta minus dt equals to 0. d theta by d theta equals m. So substitute d theta by 2 for sin theta by 2 and 1 for cos d theta by 2 is 4. So this becomes t d theta by 2 minus m plus t plus dt d theta by 2 plus m plus dm 1 equals 0. So this becomes t d theta by 2 minus m plus t d theta by 2 plus dt d theta by 2 plus m plus dm equals to 0. This becomes 2t d theta by 2 plus dm plus dt d theta by 2, that is equal to 0. So this will be equal to t d theta plus dm plus dt d theta by 2, that is equal to 0. Neglect second order term. So this becomes t d theta plus dm equals 0. So dm by d theta is equal to minus t.